Hey guys, so I did some arranging and some minor renaming and call these location, basically not the analysis. This is the actual analysis step. Actually, this is entirely the analysis step, but this is basically the end of the analysis, if you will. This is what organizes everything and tells us what the win is. So what kind of win, what did you win, and at what value is that win. This can actually be called a post-analysis. This is the numeric pre-analysis, for example. This is the complete, or we can call this analysis interpretation, if you will. Yeah, that's nice, interpretation. Or we can just say final analysis. We can call it anything we want. Final analysis is fine. I'm gonna just go with analysis again. The reason that I would like to do that is because here, as we recall, we had this artificial analysis that we wanted to do. Basically, what this means is that we would need to come all the way back here and change two things. We would need to change the numeric pre-analysis output, which gives us these numbers here, by adding or subtracting whatever it is that we want to add or subtract, and by changing the parts that, well, this part here, which deals directly with the location of these numbers. Now there is a direct correlation between the locations of these numbers in this array and in the horizontal array and in the vertical array. So where this could be located, whether here, here, or here, can vary where it is up here. So the number of possibilities that we have to, if we are going to just do the one number right there, is an enormous amount. Literally, it is an enormous amount. Because one number is just 52 of these squares, obviously. That might be the easiest to add, but then that poses a very interesting question. If that is true, then the question to be asked is, why do we need to do an analysis that relies on this? On these right here. The known cards, I understand. We have the cards that we know and we process that. But we do not need to process a new 52 deck card and then use this system to basically, we don't need to have this here and then do a comparison and figure out what should go where. Pretty much because we don't need this array right here. This array is useless to us. What we need is a while loop that whiles all those and adds a 1 wherever it is could be used. That while loop alone should basically make the whole system work. So there's a very interesting point to think about. As far as artificial analysis goes, this could make everything way faster. But for the time being, I have decided to basically ignore it. And the reason is, it is way too stressful on the system to have to deal with it. We might be able to get the one number here to run easily. We had a way to do it. Did I delete it? Yes, I did delete it. It was the one that was up here. So that was the only one that is the easiest to do. Now, in any case, the system will go through all the possibilities and tell you what the other person may or may not have. That means that only 2 unknown cards are being used, and that's it in every single iteration. So I would suggest, let us go ahead and put a huge for loop on this and see how that would function. So we need a big ass for loop from all the way here all the way to, we can put it after the win type right there. The numbers have changed. We need to bypass them. That's 1 and that's 2. There we go. They enter, they're both identical, and this should give us an indicator of the type of the win, which are all numbered up here. And let's go ahead and see how long it would take to process all of them. Go! That is it. It is done. And we can see here that most of these are 5s in this area. 5 is a 3 of a kind. So in this setup, they most likely have a 3 of a kind. This actually processed pretty quickly, which is excellent. Alright, so now that we have this array, we can do a analysis of the results. So if we are to analyze these results, how would we do that? What do we need to do? Let's see. I'm considering whether or not to do some kind of artificial analysis for these. It seems that running the system is very, very quick. So that is good. Let's try that again. Oh, did it just do it? Let's convert this to a 4 and try again. That is creepily fast. I'm not even sure it is processing, and I'm gonna save, but that's what it says, so I'm going to believe it. First thing here says I have a 2. A 2 would imply a full house, so I have 4, 4, 4, 2, 2. And let's just make sure that 2 is a full house. 2 is a full house. How many 2s do you think are here? We can go ahead and do a sorting of this array, and let's see what that would look like. Run it again for this system. Aha, now it's taking a while. Whoa, there is a possibility, one possibility, to have a 4 of a kind. And that is, how is that possible? That's 2, 2. Someone could have a 2, 2. That's it. There's only one chance for that. Otherwise, most people have 2s. As you can see, here are the 2s. Then here are the 4s, and so on and so forth. Let us go ahead and do the following. Let's take the sorted array and let us do the following. Let us do searches on it to figure out what is where. So let us do this 9 times, because we have 0, 1, 2, 3, 4, 5, 6, 7, 8. Take in the entire array as a shift register. Do a location array. Let's see. Search this array for 0, and basically array get an array subset from index to the rest of it, and okay, let's do something else. Let's do array delete from array. Yes, so let's delete from this array from a certain index. Let's see how this works again. So we delete from a certain index a length of 1. We don't want to delete a length of 1. We want to delete, well, let's not delete. Seems too complicated. Again, I'm gonna go with an array subset. So array subset from this index, and that will go on. What was left behind is wherever this index is. So this index is actually going to be what's left behind. Create an indicator of that. This should give us how many of each thing there are. Let's go ahead and check. It should give us 1. Whoa. -1, 0, 1, -1. 321. So if it didn't find any, it gave us a -1, that's fine. So it didn't find any zeros. It found 0 of those. So what we're going to do is we're going to take that and do a +1 to it. That should give us a more accurate number. Let's run that again, and that should be the right number, hopefully. There we go. So it found 0 zeros, 1 1, 2 2s, no 3s, 22 4s. Is that true? That cannot be true. Let me look at this array again. So there's no zeros. There's 1 1. There's 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21. So there could be 22 2s. Could there be 49 4s? Let's go to 22. It is possible as well. This is very... I don't like this. Let's do a split. Sort 1D array, search 1D array, split 1D array. So split this array at this index. Let's see. First subarray, second subarray. So we split it. The second subarray goes on, and the first subarray, just give me its size. Let's see, what does this give us? Whoa, even worse. How is that possible? Okay, let's run this one time and let us see what is going on in here. The inputted, create an indicator of the input and create an indicator of the output. Here's the input, here's the output. Let's check those two. Input output is identical. Let's run it twice. Input should be the 1, output should be from the 2 onwards. No, it did not cut it. Why is that? Because the index here is 0. If we add a 1 to it, there we go. That's more like it. Now let's do this 9 times. Nope. 9 times and it ended with 7. So it's doing that problem again. Alright, well, I'm gonna end this video here, guys. I'm sorry, I've been ranting for so long. I'll investigate how to make this work and I'll let you know next time.